This is a video presentation for Limnology at Georgian College, the Barrie campus. The project is called Looking in Depth at the Parameters of Lake Baikal, and it is developed by myself, Kirk Weimer,
myself, Dylan Patterson,
and me, Jonathan Larocque.
For a basic introduction, we'll look at Lake Baikal. Lake Baikal is the world's largest lake based on its volume, accounting for approximately 20% of the world's surface water. This is not including the glacial water that is frozen. The volumetric amount is equivalent to 23,615 cubic kilometers. Lake Baikal is a rift lake. This means that the lake was formed from fault line movement on a rift zone due to the tectonic plates. Lake Baikal can be found in the southern region of Siberia and Russia. These are two maps displaying the topography of Lake Baikal. The one on the left illustrates where the Salanga River mixes with Lake Baikal, and will be further talked about in the next article. The one on the right is a Google Map image, and as you can see on Google Map, Lake Baikal is such a massive lake that it can be seen from outer space. This map illustrates the hydrogeography of the lake. There's a maximum length of the lake which is 636 kilometers. The maximum width is 79 kilometers. The surface area is equivalent to 31,700 kilometers square, with an average depth of 744 meters and a maximum depth of 1,642 meters. The residence time of Lake Baikal is 330 years, which is quite a significant residence time, which means that it is susceptible to danger through chemical and biological parameters. The periods which Lake Baikal is frozen is from January to May, and it consists of 27 islands within the lake. In this article, we look at biological factors. The plankton composition and water chemistry in the mixing zone of the Salanga River with Lake Baikal was an article we referenced to get an understanding of how the biochemistry of the lake is changing. The results of the study show spatial distribution and dynamics of the chemistry. As well, the biological results look at the biomass and biodiversity of phytoplankton and bacterioplankton, where the Salanga River mixes with Lake Baikal. In the article, the results yielded intense development of phytoplankton and eukaryotic picoplankton, causing the decrease of nitrate and phosphate concentrations in organic matter rise were registered. Lake Baikal's biochemistry is displayed as being altered, as the river phytoplankton are replacing the lake species in the mixing zone. There is a reduction in microorganisms and organotrophic bacteria and an increase of oligotrophic and cyclotolerant bacteria.
This slide depicts various sediment cores taken from different locations in Lake Baikal. On the figure to the left, the areas that have been sampled are labeled, and the Baikal Pulp and Paper Mill and Oaken Island labeled on that figure have shown the highest amount of chemical contamination for sediment. This depicts the levels of a native species of diatoms in Lake Baikal, known as the Sierra baikalensis. This figure can serve as an indicator to the temperature of Lake Baikal according to how much of this species is present in which part of the lake.
Alright, so looking at Lake Baikal, you can understand why the chemical composition would be a very important factor on the whole general ecosystem. So in Lake Baikal, the suspended material levels and distributions of substances were analyzed. This was done for the reasoning of monitoring anthropogenic influences. Sampling was done at 3 basins back in 1994 and 1995 at central and coastal sites. These samples were 10 liters each, and one was taken from the top layer of the lake, and the other was taken from full sampler depth at each sampling site. Also, suspended material was extracted with a filter under a vacuum with a pore diameter of 0.4 micrometers. there are many elements present, as shown on the slideshow here, but a couple were calcium, tin, chromium, and lead, and many others. Their presence was determined by using this synchrotron radiation X-ray fluorescence analysis method. Elements like calcium, iron, and magnesium dominated, while tin, copper, and zinc and lead were present at smaller concentrations, less than 20 milligrams per liter. Right here is just a bit about Lake Baikal. It has a direct relation with Lake Baikal in that it has a direct inflow into the Lake Baikal itself. It's the Iztok River. In here, the survey was conducted due to some cases of HAF disease in 2008-2009 from the consumption of fish from Lake Baikal for a potential indication of cyanobacterial toxins in Lake Baikal. It is stated that there was a present mass development of Aphanocapsa holistica in Lake Baikal. Cyanobacteria were the most abundant phytoplankton group, and Gliotrichia ahenulata was the dominant species of this. In the bottom right-hand corner, there's a table. It's the mean limnological variables at the central pelagic site. So this is the center testing zone, and they have depths for Secchi depths, phosphorus levels, nitrogen levels, and all that posted on that table there. So there was a survey carried out in Lake Baikal. There was two, so the data can be contrasted, but it was near urban settlements and construction operations. The fish present during the autumn or spring months were sculpin, grayling, and minnows. There's only about 25 species and subspecies present in Lake Baikal's littoral zone, which isn't really that much considering the lake's size itself. The picture on the right is a sculpin, which is a species of grayling. Actually, that picture is at Lake Baikal. And this was about really determining that climate change is affecting Lake Baikal in particular, and this was done with a recent analysis of water temperatures and ice cover. So on the chart on the right there, at the top chart, it shows a number of days, and it shows the ice duration for how many days it lasts a year. And underneath it shows the mean annual water, air, and summer water temperatures in the Lake Baikal region. There's actually a really large uptake in iron and manganese in Lake Baikal. The biota in this lake consume approximately 5% of the magnesium concentration and 11% of the iron concentration, which is a lot considering the overall volume, as discussed earlier, of this lake. And it's believed that the overall organic carbon production per year is evaluated to be 6.9 times 10 to 6 tons a year.
So this table shows the amount of the same diatoms that live in both Lake Baikal and the labeled lakes in this table. This could mean that Lake Baikal and these lakes shown are possibly connected or possibly were one large lake beforehand. And it is also an indicator of how similar the properties of these lakes are to Lake Baikal in general. These graphics are an accurate representation of the trophic state of Lake Baikal. As you can see, dissolved oxygen is higher near the photic depth of Lake Baikal and declines as the water becomes deeper. This is a characteristic of a oleotrophic lake. Keeping the topic of climate change, a peculiar effect has been made on Lake Baikal by climate change. As you can see on the graph to the right, Surface temperature has been rising steadily ever since 1948. However, at 50 meters below the surface, Lake Baikal has been remaining rather constant at temperatures. This could be due to base flow or other parameters that are buffering out the increase of surface temperature.
In conclusion, all the effects, biological, physical, and chemical parameters on Lake Baikal are quite significant when you look at it from a global perspective. 20% of the world's water resides within this lake, and having an understanding of the zones around it and the lake itself will keep it protected for future generations to come. Thank you for your time.